Dan ga ik jullie nu introduceren aan onze volgende spreker. Iemand die ons van alles weet te vertellen over het ruippatroon van Siberische zangvogels. Hij zal niet alles gaan vertellen, want dan zitten we hier nog een hele tijd, denk ik. Maar hij gaat in ieder geval ook even specifiek inzoomen op onze roetvliegenvanger. Heel erg relevant voor de identificatie, heb ik me laten vertellen. En ja, daarom ontzettend bijzonder dat hij er is. All the way from Stockholm. Welcome. Thank you very much for coming here. En mag ik een daverend applaus voor Magnus Hellström.
Thank you very much. Yes, like Peter said, like I think Peter said, I don't understand any Dutch at all. I'm going to talk a bit about Moult today. And I do very well know that Moult may not be the sexiest thing to present on a stage like this. But if you try not to fall asleep, and I will try to show you that this is actually super relevant for the identification of quite a few Siberian vagrants that we get here to Western Europe. I also know that this may not be new information for some of you, but since most field guides actually fails to mention this phenomenon that we will discuss here today, I still think it deserves to be repeated again. Yeah, how do I? Oh, good. Okay, there are a few boring slides, but they are quite essential in order to understand the process here. So you just have to bear with me through this one. This is an annual cycle of most European passerines, more or less any European passerines. If we start here at 12 o'clock. Oh my God. Yeah, okay, yeah, sorry. If we start 12 o'clock, we see that our passerines in Europe, they spend a couple of months on the breeding grounds. They have an autumn migration. They spend a couple of months on the wintering areas, and then they have a spring migration, and it all spins like a wheel over the bird's lifetime. What is also very clear from these photos, from this slide here, is that we have two distinct molt periods during the year. We have a molt period after the breeding and before the autumn migration is initiated. The juvenile bird performs its post-juvenile molt during this period here, and the adult bird performs its post-breeding molt. And once the molt is finished, the bird initiates its autumn migration and disappears to the south. Some birds, that's why we have the brackets around the pre-breeding molt, because not all birds has it. But during the winter, quite many tropical migrants also has a winter molt. But today we are primarily focusing in this molt during the late summer, the post-juvenile molt and the post-breeding molt. So remember, that's super important in order to get this, that in Europe, for European passerines, the rule is that the molt is conducted before the birds leave for the autumn migration, generally very close to their breeding grounds. And this is the reason why we don't see, oh my God, me and technics. It's the green one, right? Yeah. So this is actually the reason why we don't see juvenile robins during the autumn migration, because the juvenile robin has already conducted its molt close to the breeding ground. We see them maybe in gardens and, yeah, you know, where robins breed. And after that molt, they look like this, and then they initiate autumn migration. And again, this goes for more or less all European passerines. 1 and 2, yeah. So, if this is true then, how come that the young Pallas's reed buntings that have been recorded in Europe look like this and not like this, as they may be expected to do. And that's what we will take a closer look at here today. The short answer to this question is that there are a number of Siberian species that, quite oddly enough, leave their breeding grounds and initiate the autumn migration in more or less unmolted plumage. They start the autumn migration before the molt. 1, 2. Good. So then we have the European birds to the left. It's the same figure as you saw earlier. On the breeding sites, after the breeding, the bird conducts their molt. Standard European molting pattern for passerines. But there are then a number of birds in Siberia. Those are the species that we will talk about today. That actually look like this. After the breeding, they leave the breeding ground, initiate the autumn migration, then they have a migration stopover, more or less halfway on their migration, then continue to the wintering grounds, and the wheel spins like this for this species in question. And remember also that this applies both to the post-juvenile and the post-breeding molt. So it actually concerns both the juvenile bird and the adult birds. If we take a look at the geography, it looks kind of like this. The birds leave their breeding range unmolted, more or less halfway down to China, where they perform their molt, both the adult and the young bird. And once that one is completed, they continue down to the wintering areas further south in Asia. As I said, this molt pattern is very rare in Europe. One of the very few species that actually do show it is the common rosefinch. They do more or less like this. But then again, we should remember that rosefinches actually is a Siberian species that has spread west into Europe. So yeah, it kind of still, it doesn't destroy the general pattern here. Last year, yes. Last year, Phelan Heim published a study where he used light loggers on a number of yellow-breasted buntings that he trapped in eastern Siberia. And the results here are very interesting. It showed that the birds departed very early, directly after the breeding. Already in late July and early August, the bird left their breeding grounds in southern Siberia. And they later on performed a stopover in this region here. And this stopover was about 50 to 80 days long. So like 1.5 to 2 months, more or less. Just enough time, of course, to perform their molt. And after the stopover, they continue down to the wintering areas further south in Southeast Asia. So the results from this study perfectly matched the theories that we have that we earlier have presented from observing the molt of the birds in China, Siberia, and Russia. I hope for more of these studies in the future. And before we take a closer look at the birds, I think we should also ask ourselves why the birds do like this. Why does the Siberian birds behave like this? And to start with, rearranging the time schedule in this way means that the birds get to leave considerably earlier from the breeding grounds. This is the Siberian birds. You see, compared to our European birds, they leave more or less 1.5 months earlier from the breeding grounds than our European birds does. And I think that one very likely factor to play into this is probably the extreme inland climate in Siberia. Already in mid-August, the night temperature often reaches 0 degrees or sub-0 degrees, even as far south as in Mongolia. So it really is a rather, temperature-wise, is a rather hostile environment. But I don't think that the temperature is the only reason for this moult pattern. Partly because this moult pattern is not consistent among the Siberian birds. There are other moult patterns present in other species. That's one reason. Another reason is that quite many of the birds that shows this moult pattern are actually seed eaters, and it seems reasonable to expect them to be less sensitive to lower temperatures than compared to insect eaters, for example. So. There are most likely further explanations why this pattern has evolved, and I am very curious to see any contributions, any future studies of this subject. It should also be mentioned that the presence of this moult pattern seem to decrease the further or the closer you come to the Pacific coast. Personally, I have thought that this is probably because that the higher, that the less extreme inland climate probably provides better conditions for the birds to molt when you come closer to the shorelines. You have more even and higher average temperatures. But again, it's a subject for future studies. So, okay, what species or which species is actually doing like this, behaving like this? Well, to start with, already in 1991, when Per Hellström and colleagues published his book, Rare Birds of Britain and Europe, he makes a few very interesting notes about 3 different buntings. For yellow-breasted bunting, he says that, surprisingly, the juvenile plumage is at least often not molted until the wintering quarters. This may be the usual strategy, but further research is required. But obviously, Per was on to something here, because this is very much true. This is how they do behave. But then, if we continue with chestnut bunting, Per writes that the juvenile plumage is molted before the autumn migration and thus very unlikely to be seen in Europe. However, the Norwegian record concerned a juvenile. So yeah, he do thinks it's unlikely, but it still notes that there was a bird in juvenile plumage recorded in Norway. And kind of the same is mentioned for Pallas's reed bunting. It would seem very unlikely for a juvenile bird to reach Europe since they usually molt before migration. But in fact, the second European record was of a bird in full juvenile plumage. And so, yeah, that's very interesting. And what he doesn't mention here is that actually the first individual in Europe concerned an adult bird in autumn, and that one was also unmolted. So both the single 2 records of Pallas's reed bunting by then was both concerning birds that did not, that had not performed any molt yet. So, okay, which species? Well, at least these ones. We have the top group here with dark-sided flycatcher, common rosefinch, yellow-browed bunting, yellow-breasted bunting, chestnut bunting, Pallas's reed bunting. These are prime examples of these moult pattern. But then we also have, for example, brown-shrike, Richard's pipit, Pallas's grasshopper warbler, and lanceolated warbler. And the reason why they are within brackets here is that although it's true that the juveniles leave the breeding grounds more or less unmolted, it's not fully true for the adults, because adults of these individuals, they initiate a complete molt on the breeding ground, but they halt it. They suspend the molt and then perform the migration and continue to finish the molt while when they reach the breeding grounds. So they are not quite as shining examples maybe, but it's still some kind of a, it's a part of the pattern that many passerine species seem to be in a hurry to leave Siberia. Okay, let's take a look at a few of these species, and I have only chosen a few species from the top group here. This one, oh my God. Yeah? Okay, this one I think you are very familiar with since last autumn here in Holland, the dark-sided flycatcher. In all the slides I will show you here now, we have some, I have the juvenile birds, the young birds on the top row, and I have the adult birds on the bottom row. It's the same arrangement for all the species here. So, like many other flycatchers, in the juvenile plumage, the dark-sided flycatcher is rather heavily spotted. You can see that the body, the upper parts, is heavily spotted. The head, you can see that the breast also give a very spotty appearance. And you also note here that you have these pale spotted median coverts and heavily patterned greater coverts as well. So this is how the dark-sided flycatcher look when they leave the breeding grounds. After the stopover molt in China, the young bird have performed a partial molt. It has molted the whole body. You can see that most of the pale spotting is lost, including the pale spotting of the median coverts here. But they do retain more or less all greater coverts. So you see that the wing is still juvenile. The tertials, the greater coverts, and the primaries and secondaries are still juvenile. But this plumage transition here is because of this partial post-juvenile molt that they conduct on this stopover molt. The adult birds do more or less the same, but it's you don't see this transition, this sharp transition between the plumages, because the worn adult plumage is rather similar to the fresh adult plumage. It is, you know, it's the same feather generation that is molted, so you don't have any differences in pattern. The only difference you see is the one in wear, that this very worn wing in this autumn dark-sided flycatcher. Compare that to this very fresh wing that you see a couple of months later after their complete molt. You have a partial molt here on stopover. Here you have a complete molt in the adult bird. So the whole plumage, including the wing, is very fresh in the adult, in the molted adult dark-sided flycatcher. Okay, but if we then take a look at the European records, the first two records of dark-sided flycatcher was a bird from Iceland in 2012 and a bird from Norway in 2023. And both of them are very easily identified as juvenile birds. It's rather obvious. You see, they are both heavily spotted, both above and below, and they still have juvenile median coverts and greater coverts like this. So the first two records look like this. By the end of my presentation, I will come back to the Dutch bird, and we can take a closer look on that one together. So, and then we change species to the yellow-breasted bunting. Again, we have a juvenile bird upper left here. before the molt. We then have a juvenile bird after the molt here. And on the lower row, an adult unmolted bird and an adult molted bird. Before and after the stopover molt in China. So, as a general rule for the Emberiza buntings, the juvenile plumage is rather easy to identify because they have a specific pattern to the median coverts. You see that they have a very distinct black center that has the shape of a very narrow tooth on the feather. And this is how more or less all juvenile Emberiza bunting looks like. So, yeah, otherwise you can see it's a little bit more streaked, both above, especially on the head maybe, and also on the breast and breast sides. But then after the molt in China, it turns into a different bird. You can see that the median coverts, they are all molted and they now have a different pattern. The same goes for the adult bird. We have a very worn breeding plumage by the end of the summer, and they leave the breeding grounds like this. Could very well turn up in Europe looking exactly like this during the autumn. But you do see that the wing here is very, very worn. And compare that to the adult male after the stopover molt in China, where it's perfectly fresh and good looking in every way, but it has lost the typical traits of the breeding plumage, of course. And if we take a look at some European records of yellow-breasted bunting, it looks like this. This is how the vast majority of the yellow-breasted bunting looks when they are recorded in Europe. And you can see from all these four birds, we have Finland 96, Denmark 91, Sweden 2012, UK 2017, just 4 examples. And you can see that all of them are still in juvenile plumage, showing this typical juvenile pattern to the median coverts. Same on all 4 birds here. So this is more or less what you should expect from a yellow-breasted bunting recorded in Europe during the autumn. The option to this would be an adult bird, which then are most expected to show a heavily worn plumage, just like this one. Yeah, we change species to the chestnut bunting. Again, we have the same story here. The juvenile bird up to the left. Juvenile plumage is a little bit more streaked like this, but most easily it's recognizable because of the pattern of the median coverts with this black tooth in the center of the feather. After the molt, the young male look like this. You see the median coverts has lost this pattern by now. And the adult bird, similar to the last examples, a very worn breeding plumage is what is expected from adult birds during the autumn migration. And after the stopover molt in China, the same individual turned to this fresh beauty. And a couple of European records: France 2014, Norway 2010, Finland 2018, UK 2015. All of them birds in a fresh but juvenile plumage, completely juvenile plumage. Juvenile median coverts are present, more easily seen on this bird perhaps. The same goes for this one and this one. And it should also be noted that in juvenile plumage, it's not advisable to sex birds, to sex these Emberiza buntings, because the males and females are practically identical. So as long as they look like this in a fully juvenile plumage, just leave them without any sexing. Yeah, and then we have the Pallas's reed bunting again. Again, the juvenile bird upper left here, rather heavily streaked, and the typical tooth-shaped pattern to the median coverts. After the post-juvenile molt, after the stopover molt, the young male look like this. It's a huge difference between these plumages. While the adult bird, just like the other examples here, have a very, very worn wing when they leave the breeding grounds in Siberia. And later on, after the post-breeding molt, turn into this very fresh bird. Super nice. This is an adult male as well, but it's very fresh. It has just conducted its post-breeding molt. One thing that we should mention here that we see on the lower left bird here is that there is actually some signs of ongoing molt here. And it is true that they leave the breeding grounds in more or less unmolted plumage, but it's not unusual that you see that the bird has performed some molt of the body feathers. Usually it's somewhere in the head, that's a few feathers may have been molted, or maybe somewhere on the breast. That's you can see that. You can see some contrast between these fresh-looking feathers compared to the streaked and more often less colorful juvenile ones. And we have one example of such a bird here. Again, these are 4 different European Pallas's reed buntings. The first one here from Sweden in 2016 was primarily in a juvenile plumage. The whole wing is still juvenile, and much of the upper part is still juvenile. But you can see this unstreaked area here, and there were also, on the other side of the head, it also showed some signs of molt, and perhaps these may also be newly molted post-juvenile feathers that we see here. But still, basically, it was a bird that gave primarily a juvenile impression. UK 1981, this is the bird that Per mentioned in his book that I showed you earlier, completely juvenile plumage. The same goes for this bird from Italy in 2017, also completely juvenile. But then again, we have the record that Per mentioned in the book from UK 1976. This bird shows some clear abrasion. It shows a clear wear present in the wing in the photos here. And it was also noted in the description that we have many feathers that were heavily abraded, and primaries and secondaries much abraded. So this is actually then an adult bird. And yeah, as we know by now, even the adult bird leave the breeding grounds and start the autumn migration before the molt. Yeah, nice. Then I want to show a few slides and talk a little bit about this bird from last autumn here in Holland. I hope that many of you got to see it. We still have no records in Sweden, so I'm very jealous about this. Okay, by now we have concluded that the dark-sided flycatcher, this one, do not behave as some other relatives in Siberia. For example, the Asian brown flycatcher that we see here to the left. These birds are actually both first calendar year birds, but this is how a flycatcher looks like when it hasn't performed the molt, and this is what a flycatcher looks like after it has performed this post-juvenile molt. It has lost the spotting that also the Asian brown flycatcher have, but you still see that there are some juvenile greater coverts and juvenile tertials present in this bird. So the same bird, but they have different molt patterns. As we mentioned before, the first 2 European records of the dark-sided flycatcher concerned such birds in juvenile plumage, just as expected. But then the Dutch bird, it really don't quite match up with this, right? Instead, it actually shows a rather typical adult type plumage. A closer look at it also shows that the wing is of an adult type. It lacks this typical juvenile pattern that we see on the young birds, on the greater coverts. And the same goes for the turtles, and yeah, it's basically an adult pattern bird that we see here. So clearly, this bird is at least 1 year old then. But this is where it gets fun with the dark-sided flycatcher, because this species is rather unique when it comes to the aging. I will try to show this in detail here. It's another boring figure. Imagine a dark-sided flycatcher that is born during the summer in Siberia. It leaves the breeding grounds during early autumn, flies down to somewhere in China, performs its partial molt, then continues to the wintering grounds, and during the winter, before the spring migration, it once again conducts a partial molt. But note here that both these molts are partial. That means that the wing is not molted here and the wing is not molted here. So the wing is actually still juvenile. It's juvenile all over the breeding season. It is also juvenile when it starts the autumn migration, and only when it reaches the stopover in China during its second autumn is where it performs its first complete molt. So all the way here, the bird actually still has a juvenile wing. If we then apply some logic to this, it means that we actually, before the complete molt here, before the molt, we have 3 different age categories that we can separate. We have the young bird here that has a very fresh juvenile wing. We have the second calendar year here that shows a juvenile wing as well, but it's very worn. And then we have the adult generation that is also quite worn by now, but it is of an adult type pattern to the wing. So before the molt, we actually have 3 different age categories to consider, and that's very unique. There are only a few other examples from the Palearctic where we can separate 3 different age categories during the autumn. After this molt is conducted, the first complete molt here, we don't have the possibility to separate 3 age categories anymore. After that, we can only separate the first years that has a fresh juvenile wing from the adult bird that has a fresh adult wing. And we have to age them a second calendar year plus then. And if we take a look at some real bird photos here, on the top row, you see a young bird in fresh juvenile plumage showing typical fresh juvenile pattern to the median coverts, to the greater coverts, to the turtles, and the wing is very fresh indeed. If we zoom in on the greater coverts, you can see a rather typical pattern. You see that these wide, pale tips to the greater coverts, they are like wedge-shaped. They become deeper along the shaft of the single feathers. Imagine then that this bird comes back 1 year later, and as we just concluded, they haven't molted their wing yet. That means that it's the same feather generation that is still present here on the second calendar year bird. The same feather generation, but it's more than a year old. So by now you can see it's considerably worn at the tops of the primaries here. And you can also see some wear present in the alula, median coverts, and also in the greater coverts here. And if we zoom in on the greater coverts, we can actually see a ghost, a pattern that more or less ghosts the juvenile pattern. It has just worn off the pale edges here. But it's still clearly visible that we have had a juvenile pattern present on these feathers here before. They have just worn away. Yeah, and then this second calendar year bird, if we put this on the top row here, this is the same bird that we just saw on the bottom row. But then we compare it to an adult bird that has not conducted its molt yet. That adult bird shows then a worn adult type generation wing. And if we zoom in on the greater coverts, we see the typical adult pattern. You don't have this pale tipping that we saw from previous birds. Instead, they have a rather evenly neat pale edge and pale tip that runs around the feather tip like this. So we actually then have 3 calendar year plus. We have second calendar year birds, and from the former slide, we have first calendar year birds. Those are the 3 age categories to consider when we have an unmolted bird to...
Okay, well then I would say Magnus for giving this presentation. Can I have one last applause for Magnus, please? Thank you.
Thank you very much.